Alright, let's just have a quick look at our cos graphs now. We can apply a really similar idea. And we can manipulate our cos graphs in the same way that we manipulate our sine graphs. It's just that it's going to look a bit different after manipulation. Just to keep in mind here again, when you're looking at the period, you really want to be finding 2 pi on b, whatever the coefficient of x is there. That's what you want to be looking for. So if I look at my standard cos graph, right, I have something like this, 0 to 2 pi. Okay, and you know that you start at a height or y value of 1, go down to -1 there. And so that's why you have your amplitude of 1 and period of 2 pi, right? Because the coefficient of the whole function is just 1, and then there's no manipulations done inside there. When you get to something like this though, right, you can see we do have a coefficient now in front of the whole function multiplied by 4. So again, before I'm doing this, I just want to make a note of any values. So I've got a equals to 4. My period is still going to stay the same. That's just going to be 2 pi. And so before I even do any markings, I'm just going to sketch it, right? And now I'm going from 0 to 2 pi. And because I've sketched it like this, now I can just put in the values when I'm done. I'm going from 4 to -4, right? Because when I'm looking at the amplitude, it's the distance from the center axis to the furthest points away. So I got 4 to -4, 0 to 2 pi, and that's y equals to 4 cos of x. Unlike this though, when I've got, should be some brackets there, when I've got some manipulations inside the bracket, then I need to thinking about the period there. When I've got a coefficient of 2, what that means is my period is going to be equal to 2 pi on 2, or those 2's we just divide through, I just have pi. My amplitude is going to stay the same though, that's just 1. So, what does a period of pi mean? Well, right, it means that I expect my graph to repeat at a distance of pi. Well, really, that's just going to mean that I expect to see it twice in this interval from 0 to 2 pi. Right? And so, what I'm going to do is, I'm just going to draw my cos graph twice. 1, 2, there. And this is the point here where it repeats. That's going to be pi. And what's my amplitude? My amplitude just stays the same. So 1 to -1 there. Sweet. Let's just kind of put this all together now. In this one, I've got an amplitude of 2. My period stays the same. That's just going to be 2 pi. But what you want to be careful of is any vertical shifts that are happening, which you've got here, +1. You're shifting it up, right? So usually, without any shifts, you just have 2 to -2 using this amplitude here. But because I'm shifting it up by 1, instead it's going to be going from 3 to -1 now, right? And so my center axis is also going to change. What's halfway between 3 and -1? Well, that's just going to be a y value of 1. I'll draw a dotted line there just to indicate that's my center axis now. Everything else actually stays the same, right? The period hasn't changed at all, so my graph will resemble the same shape on that interval from 0 to 2 pi. So I would start at 3, and I know I'm going to be going all the way down to -1 there, right? So it should look something like this. There we go. Now I'll still mark on my actual x-axis there. That's going to be x value of 2 pi, and there I've got my my amplitude. I've clearly shown my amplitude there. Remember, we can also have phase shifts though, right? Let's make this 5. And that's when I have a manipulation on the inside of my brackets here, either plus or minus some value. And because I've got a negative, you can just remember, oh, I'm shifting that to the right. Or what you can try and think of is, okay, what value of x do I need for this expression to be 0? I've got x minus pi on 2 equals 0. X would equal to pi on 2. So that's where your graph would actually start, if you drew it in the typical fashion, right? So that's where your typical graph would start. And if I just draw out my intervals here, pi, 3 pi on 2, I would draw the normal cos graph, but I would start at pi on 2. My cos graph as per normal, something like that. And I'll just stop at 2 pi. And the question is, what's happening before that? What you can do is you can just extend the graph as per normal, but what you might also want to do is just check when x is equal to 0, what's going to happen? Well, you have cos of negative pi on 2, right? Which, if you put in your calculator in radians zone, turns out to be 0. And so I can actually continue the graph along like that. Does this look familiar though? This is actually a sine graph, right? And so that's how visually we can see that we have an identity that cos of x minus pi on 2 is actually equal to just sine of x. Okay. So that's how we can graph a phase shift where I'm moving it from left to right.